it was.
Okay.
Yeah, like, oh, actually, doctor says you have to go hard. It's not following the rules.
What?
Once you.
Yeah.
Sorry.
Yeah.
No, hey,
I feel like.
I don't print.
You make it do work. Throw it aside.
Afterwards.
Yeah. I'll be like,
Everything.
here, and I'll be like, yeah, it's obviously not following the rules here. We have.
What does that mean?
All right, should get started.
Yeah.
So, what is coming? What an awkwardly placed scenario again, I'm seeing everyone. All right. Sprint 210. How did it go? I've heard some interesting things so far about how the end of Sprint 2 went.
So I locked Robert in the programming closet and I paid the notice how much I had to leave and it got all done. So
Now, see, if I said that, I wouldn't have a job anymore.
You just have to qualify with that in Minecraft.
Yeah.
In a video game environment, I did this too.
So today is officially the start of Sprint 3. I was frantically trying to get that up before coming to class, and I was oh so close. Everything is written. I just need to make a couple last minute changes to the rubric to make sure that I'm copying this from before, where there used to only be 3 sprints and not 4 sprints. So I have a little bit of modification to do to lessen the burden of Sprint 3, because some of that is being pushed to Sprint 4. So it needs to show up in the rubric as well, so that you know exactly what you're being graded on from the first day. But the wording of exactly what the client needs from you and exactly what I, the project manager, need from you is clear and will be posted minutes after class ends. As long as I don't get distracted, which hopefully I don't get distracted by something more pressing.
keep distraction away.
That's good.
Save the
Because
president.
I've had way too many distractions over the last few days.
He was like, I have a question. Tackle.
You have a question in 3 minutes.
Sidebar him.
So, from what I've heard from just talking around, it seems like some of these teams could use a little bit of shuffling around. I said that I reserve the right to do this at some point, and I'm thinking that that time may be upon us. So I am considering my options with regards to trying to move forward with each team being as balanced as possible and doing having the same level of health throughout the group. So there may be some switching around. What I want to ensure at an announcement level is if you are selected to move groups, this does not mean anything. It does not mean that you are unpopular in your group. It does not mean that you are not producing enough in your group. It just means very well, maybe you are the perfect person to fill a hole in another group that I've identified could really use your strengths, or they balance out the strengths of everybody else in the team in a way that I think will improve the overall health of the groups in the class. What this means for grades, every sprint that you worked in a group, you are going to get the grade from that. So even if you are moving, it is not retroactively changing any grades. It's not changing the grade of the sprint that was just submitted. It's not going to change who you peer review tomorrow. But it would start the following week. You're going to have a new group, a new set of people to write peer reviews for, and the overall grade would be based on the project submitted for Sprint 3 that you are working on.
How did you give you this idea? This is very Tony.
No, this is something that I said from the very beginning I would do on an as-needed basis. And I think I've found a few places where some changes might benefit all of the overall teams. If you have some feedback, if you would like to send me anything about the state of your team or what you would like me to do about this, feel free to send me an email. I will probably make these changes public a few hours after class today. But if you, for instance, really don't want your team to be changed at all, or if you really want that annoying person out of your group, send me anything that you would like to make sure that I will adhere to the best of my ability. I will try to take as much of that into consideration as I can, as I come up with how to improve things moving forward.
So how much money to get Robert off? Like,
No donations. You can send me an email if that would be your preference. I know
it's a bribe.
Let's
call it what it is.
I'm gonna call it a donation, because if you give me money, it's not going to affect what I do. So it is a donation.
Tell me I can't corporate lobby, this isn't real, true life.
So, schedule moving forward. I think our syllabus says that we're down for a couple of quizzes over the next few weeks. I took a look over things and we are just not ready for quiz 3 yet. So I am placing the quiz 3 date as a week from Thursday. And that would be right before we leave, so that you two will be gone. I know that creates some scheduling conflicts for a few people in class. Obviously, I will work with you. I'm changing up what's on the syllabus. You can take it either before you leave or when you come back. I am indifferent to either of those, whatever works better for your schedule, for your studying. I will work around where you need to be at that time. But I would much rather not give you a quiz about next to no content, or that should contain content that we haven't gone over. So it makes a lot more sense to do that in about 2 weeks. Other than that, we are starting sprint 3. I'm thinking if we get through enough material today, we might be able to make a work day out of tomorrow. I would like to get kind of the design and groundwork, get off the ground running a little bit faster in this sprint. So we'll see what we get through. Yeah.
Is Wednesday also gonna be a work day?
Yes.
Sick.
Yeah. All labs are always work days. So there are a few tricky things with this sprint, but we'll get there as we need it. Question in the back?
I was just wondering if we're gonna get us any spoilers for the participant in this class.
And I can show you my current. Oh, why not? I can show you my current, I was doing this on my other machine. But I'm actually really quickly gonna bring up Canvas, and then I can show you what all of the requirements are. I only need to modify the rubric.
When are we getting the last quiz scores?
They're being worked on right now, so I like to have them turned around in a week where possible, but this was not possible for Hunter this week. It should be tomorrow. I should be able to go over it, have the rest of class be at work day, hopefully. We'll see where we end up. So here's what I have written for sprint 3. So client is going to ask us for class boxes to be draggable. When you drag, the class box should not disappear at any point. The relationship arrows should not disappear at any point. They should continue to be redrawn frame by frame at the current location if the mouse button is clicked as it's being dragged. So I should continue to be able to see where those class boxes are at all times and where their associated relationships are at all times. So you'll need some logic for how to update, for instance, what a relationship arrow looks like as a class box collides with another class box. As all sorts of interesting things happen, we want that behavior to be well defined in some capacity. We don't want relationship arrows to look ridiculous. We don't want them to look confusing. So some rules that you will need to figure out that's in some capacity for how that's going to work. Second bullet point was saving and loading. If we save in the GUI, we want to store the locations of the class boxes and the relationship arrows. So that when we load them back up, voila, it's exactly like you left it. The other part of that is if you save an existing project in the CLI, when you load it back up in the GUI, something that makes sense should happen. So for instance, I would not want to see all of the class boxes stacked on top of each other. There should be some default way to create those class boxes in a way that looks professional. At least as a starting point. It may be that those relationship arrows look pretty bad until you rearrange those class boxes into the appropriate hierarchy. But we want something that makes sense. Finally, we need undo and redo functionality in both the GUI and the CLI. So we need the ability to type undo and redo in the CLI, and we need the ability to have either keyboard commands or some kind of button to select to undo and redo.
For some of this, when Tony said it, I thought he was talking for the current thing, and I'm really glad it didn't get worked.
Yes. I've been trying to coach him on, when you say things for the next sprint, say, for the next sprint, before giving those before.
He does a
giving those
great job of
requirements.
folding them in, like, you just dropped them in, and I was like, oh
Yeah.
my god, we're getting.
Yeah, it's, no, we were talking, Colin's like, my boxes don't move yet, so I can't have them resize. So
Right.
how can I have
Right.
it save if they don't move? Oh, no, I'm like, I think that's what next print. If it's not,
Yes.
don't even have to deal with it.
I have a lot of math to rework now, because I've been going on the structure of automatically resizing, resorting, going down the list. Now I have to account for, okay, I should probably make it two options, one to like let it auto align, the second option right here, drag and drop, and now we have to rework the entire save load. for that
Yes.
structure, like, wow.
It's gonna be, there's gonna be a lot underneath the hood for this, and that may make your MVC need a little bit of work.
I'm a super genius and I can never possibly make an error that would cause issues later.
So from my perspective, from the code perspective, so nothing that is going to be visible from the usability of the program standpoint, I want you to use at least 6 design pattern instances. What I mean by that is they do not have to be distinct patterns. So if you use strategy in 2 places, if you use, that's fine, they're 2 different instances of the same pattern, but 2 of them are going to be obvious and you're basically going to need to use them. The first is MVC, you can count that as a design pattern, and second is memento that I sure hope everyone is going to use for undo redo. It makes your life so much easier. So that's another design pattern that counts toward that 6. So you just need to find 4 more. Do note that I'm looking for correct uses of design patterns. You can use more than 6. If you put in 8 and a couple of them don't work the way you think they do, I'll be able to see 6 working design patterns and I can't mark you down for that. That said, if you implement exactly 6 and a couple of them don't work the way you think they do, then I have no choice but to mark you down for not working design pattern instances. So I would shoot for the over here, especially because this number will also be going up in sprint 4. You'll be doing a little bit of work ahead of time for sprint 4. The other point of the hint here, use memento, but also the underlying structure for that is a 2-stack system. So an undo stack and a redo stack make this so much easier. You click the undo button. If you were to click redo, what do you want? The thing you just undid. You click redo. If you want to undo, what is the next thing you want? The thing you just redid. So having a 2-stack system makes a ton of sense there. Yeah.
Probably a useless question, but that's only for each run, right? Like if I load a file, I can't undo.
Right.
It's like,
Yes.
if I close it and I open it, there is no more
Yeah, you
undo.
could wipe that.
Cool.
Yeah, that you do not need to store that as part of the save file. You do not need to store the undo and redo stack capacity. Yeah. Only for the current running instance of the program. Other questions about Sprint 3's requirements? This is it. I think this is a lot more difficulty on the coding side than we've had in the past, but I also don't think you're gonna be messing with the design quite as much. Depends on how you implement things and how your design currently looks, but yeah, this is the next couple of weeks worth of work for your team. But as I noted, there might be a couple of changes between who's on what team. I will get that to you within a few hours of class ending today. If you don't hear from me, assume that you're on that team and you're good to go.
So for that, when we assigning team member to other teams, what if that team is using a different language?
That is a great question. So one team in here is using Python. I can't assume that anyone who didn't choose to be on that team wants or has the ability to do that in Python. So I would have to get your okay to move you onto a team that has Python, and the okay from someone who is on a Python team to move to a non-Python team. So if you are changing languages, I need to get your permission first.
Yeah, I'm not sure. No matter how then.
That means that
He passed it, he can do it. He can
Come
do
on,
it. He knows he can.
Swaycraft is probably the safest team, because I would have to get anyone's permission to add, to join and or leave.
Can't take any, even if they wanna leave, they're stuck. Like, they signed a contract.
Right.
I know I talk about the programming clause a lot. They're safe and healthy, even if they say otherwise. Again, non-disclosure agreement.
Not any water there.
Normal.
Yeah, they're, I do have a hope.
Yeah, it never stops.
So if we're good, then we can move on to next lecture topic. That is going to be something that will also be part of the rubric in Sprint 3, is that you're going to have to agree to code from a test-driven development perspective. So we're going to talk about test-driven development, behavior-driven development. What does that mean? What does that mean for our moving forward? So very quick review of Agile Lifecycle. We've been doing this for a couple sprints now. We're working with our stakeholders. They're part of the process. They help us to develop the requirements. They can help us to develop the acceptance tests. So we're talking to all of these stakeholders all of the time. We always have a working prototype. So starting at the end of sprint 1, you always had something that you could deliver. If there was a deadline today, if I said, you need to ship the product as it exists right now, no work would be needed for you to just take, all right, whatever happened at the end of sprint 2, that's our project. You can have the current working version of it. Is it everything that I ever hoped and dreamed it would be? No, but it works. So we talked about validation versus verification. We checked in with stakeholders. What do we need to do next? Validate that you're building the correct thing as you do it. So let's talk about the two main ways to develop. So in behavior-driven development or behavior-driven design, you're going to develop the user stories, as we've been doing, the features that you wish you had, describing how your application is going to work. The user stories become acceptance tests and integration tests by this concept called Cucumber. That's just the term for using the tests that you write. Using the user stories that you write as the tests for whether you develop the right thing. So that's behavior-driven design. We're going to design this based on the behavior that we eventually want to have. Contrary to common belief, these are not separate things. You don't adhere to either BDD or TDD. You can do both. So test-driven development is going to be, how do we actually go develop it? So behavior-driven design is about the design process. How are you designing the application? And you're going to design it by talking to the stakeholders, keeping the stakeholders involved. You're going to develop via test-driven development. So that tells us that we are going to be writing tests before we write code. Without any code whatsoever, we're going to have written the tests that are going to accept the code that we eventually write, saying that we are done. First of all, does this seem like a good idea or a bad idea? I get a lot of both in software engineering types of classes, but does anyone want to comment on the thoughts of what do you feel like the benefits or detriments would be if you started writing tests before you've written any code at all?
The obvious benefit is that you test something that works.
Yeah,
first, and that the main functionality is valid before throwing it into the actual project within the bounds. The downside is that's time away from actually adding it to it. And if it's testing for something that's trivial behavior, it's a waste of time.
okay. So maybe there's some limitations we should put on what kinds of tests should be written before we write code. That seems reasonable, yeah.
I think it can kind of lead to the pitfall of thinking about it in a very specific way. So what you're thinking of how it works is not actually how it will work, so you can waste the time writing tests that don't match what the like actual end step will be. If that
So
makes
imagine
sense.
you have the design. So you have the design, it's been okayed from the management level that says, we believe that this design will eventually produce the correct product. If you're wrong and have to go through a redesign after you started writing the test, I agree that that is terrible. You're gonna have written a bunch of tests that get scrapped because things have changed. But if you had that design in place from the beginning, you could write tests to that design that says, how do each of these components of this product work independently? We could write unit tests for each of those components. How are these components going to be communicating with each other? We could write some integration tests before we've written anything that says, once this component exists and this component exists, how do they communicate with each other? You could write some acceptance tests at the end that says, if we sit a user down and they use this for some amount of time, how do we know that it's done or not? We get that in writing before we actually have a product. This one was fun, yeah.
Can you elaborate on the cucumber?
Yeah, so it's just a term that basically, it's a software engineering term of going from user stories to acceptance and integration tests. So once you have your user stories, using those user stories as those tests is known as cucumber. And I can even show you I should have a little bit more here for this, but if we. Let me edit. Blah, blah, blah. I don't like going through Wikipedia too frequently, but software tool used for BDD runs automated acceptance tests written in some kind of BDD style. So it's the software that allows that mapping from user stories to tests. So runs those tests that are written in that form to be able to say, yes, you're done, or no, you're not, in a way that's been agreed upon between the client and the developers.
So, for example, like if we want to able to drag the class around, that's part of the user story
Right,
that get written to the behavior test, and then you can mock the class drag.
right, yeah. Yeah, we would be able to say something like, the only way that we know that this has been implemented correctly is if you could even write a test that says, I make this class, this class, this class. And then they have a particular relationship hierarchy. When I drag this over this and on top of this, this is the exact behavior that we would want to see with regards to that. That becomes an acceptance test that says, if you could find some way to write that, or you want something a little bit more technical. But a way that shows, yes, this is what we were told to implement. So this is a very fun, does anyone remember well, first of all, Zunes are long gone. But fun bug of what happened to all Zunes when 2008 turned into 2009. Is anyone aware of what happened?
Wasn't that a leap year?
It was a leap year. There was a leap year bug associated with that. But basically, every Zune tried to restart at that point. And because the date was invalid, it could not start. There was no way to get an automated update to it to be able to do that. So everyone's music player just stopped working on that day because of a date-related bug. Literally turned into a brick. And you can see this is the exact code that was done for that.
I mean, it's just makes sense.
So, yeah,
Yes.
on 12/31/2008, this is what you had, and at midnight, this is what you had.
I'm trying to think of the logic of what he was doing.
So there are plenty of examples of you write the code and then you write the test to the code and you may not be able to see everything. If you are thinking about those edge cases, even before you have the code in front of you, you're not biased by the code that you have written. You're working just off of the testing of the specs, testing off of the specification that allows you to determine what the behavior is going to be. As soon as you start writing the code, you're gonna be referring to the code as you write the tests, and you're biasing yourself. Now some quotes. If you're gonna test first, so test first code tends to be more cohesive, less coupled than code in which testing isn't part of the intimate coding cycle. This just means that if you have the code in front of you, you write tests for that code. So you end up with code block, test written for that code block. Code block, test written for that code block. So that's what they mean by coupled. If you write tests first, then you're not going to couple them quite as much. You're still gonna write the code to do the idea in general, but the tests aren't written for the code. The code is more so written in general, and hopefully the tests still pass. The other idea would be if you can't write a test for what you are about to code, you shouldn't be jumping off the deep end and starting to code. If you don't know what the behavior of your code is supposed to be, how can you hope to implement it? So one argument against might be that, well, we don't have the code in front of us. We don't even know what we need to be testing because we haven't implemented it yet. And the rebuttal to that is, if you need to write the system before you can test it, then you're not doing enough planning. You should know the system very well before you start.
I don't think I like this guy.
So extreme programming, I actually did not go over this small lecture. So extreme programming is taking the concept of an iterative waterfall and turning it into the extreme. So now you're going through the entire process every week, every few days, maybe even once a day. You're going through the entire development cycle so that you can release a daily build, so that you can release something else. So extreme programming is what has led to something like test-driven development. So this is paired very well with that idea. So we want to develop software, not just the testing software. We're going to be developing the software in short iterations, but we develop our tests before the code. And this allows us to target, if we're only going to be writing a little bit of code for the day, we can write the tests for that little bit of code before we write the code, so that we can verify at the end of this, did we write the code that we needed to that passes all the tests that we wrote for this small code snippet. So the idea, how it works. Step one, add a test. We need to refer back to our user stories to understand the requirement, but we can write tests directly off those user stories and scenarios. If we have an existing project, if we're writing a new test, that test should fail because it is for some functionality that we have not implemented yet. So we run all of the tests, everything else should pass, the test that we just wrote should fail. Because it is testing functionality we haven't written yet. This tells us, one, all of the tests are working correctly. And it also ensures that the test that we are writing doesn't accidentally pass. If we write a test for some feature that we haven't implemented and it passes, that is a flaw in the test that we need to go fix. Once we see that we have a bunch of tests passing and a test that we just wrote failing, then we're ready to write the code. That the idea of writing that code is to ensure that the functionality is there, the new test should pass by the time we are done writing that code. Only write the code designed for that test. You should not add any additional functionality because that functionality doesn't have tests written for it yet. We need to circle back now to step 2. We're gonna run all the tests. But now we should see all the tests passing. If we've written the code for the functionality for those tests, then those tests should pass. If they do, and we wrote enough good tests, then we can assure we met the requirements. Once all of that is done, then we just need to make sure that the code is clean. Run the tests again after cleaning up the code, making sure that the code cleaning didn't break anything. But the idea is now we know we have clean code that adheres to the new requirement as well as all of the old requirements. And all of the tests we have ever written pass for all of the code that we have written. So go back to the beginning, implement a new feature. Well, you don't want to implement it yet, you want to write the tests for the new feature, then implement the feature, then run the tests and make sure that the new test that you wrote now passes after implementing, and just cycle that. And you can see that this is a very small process. So it makes sense to pair it with extreme programming. This is kind of a logical view of when are you going to write the tests for things, given this general process? So pick the functionality, over here, pick the functionality. You either write the test or you write the code. And you can see how production code until the test passes, we're going to iterate on the code based on the test. Here we wrote the code, so write tests to validate that the code that we wrote passes all the functionality that we require. Then we run all tests and rework code, and now we're able to go back and repeat. In terms of a flow diagram, we go from the user story to working on the next user story, just kind of following one or the other of these. So test-driven development is on the left, and more of testing at the end is on the right. Of all of the things that I am going to discuss over the course of this quarter, this might be the one that gets the most pushback. So it's worth diving into a little bit more of the actual statistics behind development that takes place, testing first and testing last, as well as some survey results of talking to developers in the industry about when should you be writing the tests. So we're going to go into a few different research studies about this. And it's good to go back in time a little bit with this because I feel like it was more pronounced when we had fewer tools available to automate. So things have kind of moved a bit towards the middle as we've been able to automate some additional tests and write them with more efficiency. But this one's a bit of an older test. So the background to this is we had juniors in college in an 8-week Java course. The outcomes of the class, they needed to learn JUnit, learn design concepts, and learn OO code. Broke these students into 2 groups. We had the control group that wrote their tests last, and the test-driven development group that wrote their tests first. Each group developed a game. The study wanted to see, could the test-first programmers, would they write more tests per unit of programming effort? If we said, write the test first, how many tests were written? If we said, write the tests last, how many tests were written? We could just look at how many tests people decided were enough tests. The next question was, do those who write the tests first produce a measurably better bowling game than those who wrote the tests last? In terms of functionality, who wrote the buggier code or the code that was the most bug-free? And then we looked at the total productivity overall of that. So how many lines of code were written over how much time? Did writing more tests improve the quality? Did writing more tests increase the productivity of the coders? So results to this showed that there was actually no quality difference. Both teams produced a reasonably bug-free bowling game, both groups. Productivity, on the other hand, those who were test first had better task understanding. They knew what they needed to do sooner. They had better task focus. Once they were assigned a task, they were better able to focus on that. They did not get distracted as much. If they had questions during the development of their program, if they had written the test first, they were able to get those ideas meaningfully faster. There was less rework effort, meaning that there was less cycling back to something that had already been written and trying to debug it. They also wrote more tests per unit of programming, so more tests were written for the test first games. And then finally, more of those tests led to proportionally higher levels of productivity. Because more tests had been written, and because people had a better understanding of what they were doing while they were doing it, they were able to produce the product faster. Which is intriguing. Study number 2. We had 2 groups again using pair programming practices. Control group used a regular waterfall style approach, and another used test driven, where we were going to write the tests before we wrote the code. Some results to this, I guess we're still looking at the research hypotheses. We would figure that the code on TDD, was that going to be superior to code developed with waterfall? And could they develop the application faster than via waterfall? And for this study, those who wrote the tests first passed 18% more of their test cases than those who did not. And by an external review of their code quality, they had higher levels of code quality. In terms of productivity, the test first programmers took, in this case, more time, 16% more time for development than those who were just in waterfall. Code coverage, we're actually going to talk about code coverage in a lot more detail not momentarily, but probably next week. But test cases achieved 98% code coverage, 90% method coverage, 92% statement coverage, and 97% branch coverage. In general, writing the tests first, which showed that there was a significant amount of the code that actually had tests written for it. So again, we'll talk about that in more detail, exactly what all of that means later. But it was interesting, there was a slightly different result here. It looked like the quality was higher, but the productivity was worse. In terms of last time, the quality was the same, but the productivity was better. So a third one, actually out in industry rather than in the classroom. So the background of it, IBM found that the defect rate was too high. unit testing process was not very disciplined, done kind of after the fact. So with TDD, we wanted to figure out the associated defect rate, productivity, testing frequency, design, and integration. 80% of the important classes were covered by some kind of automated unit testing. And after TDD was done, the number of errors per 1,000 lines of code was almost cut in half. The productivity was still acceptable. It was not as high as it had been. It was a little bit slower development, but it was still reasonable. And then how many tests were done? 2,500 automated tests run daily, 400 interactive tests that required you to actually use the program were run less frequently. So let's talk about some of the benefits to it. Why would you decide to use test-driven development? You get instant feedback. You write some code and you have the ability to immediately know, is it good? Does this do what I think it does? That's kind of important, right? To have that level of instant feedback. You write some code, if you don't have a test written for it yet, you either have to now go write the test. And if you developed something that wasn't thinking about all of the requirements, are you gonna write tests for the missing requirements, or are you gonna be biased by the code that you just wrote? If you wrote the tests first, thinking about just the design, then you'll be able to see what I just implemented passes all of those tests. You get some healthier development practices. Developers are going to be thinking about decomposing the problem into tasks ahead of time. If you're writing the tests and organizing the tests, you're not just jumping right into the code. You'll be doing a lot of the design that you already have to do as part of the coding process, but doing it earlier. Doing it before you start. This also helps you to figure out why design decisions were made. You can look back at the tests if you ever want to figure out, why did we do this way? If you focus only writing the code necessary to pass the tests, then the actual design turns out to be simpler. It means you're focusing on exactly what you need to be focusing. And less, what if we, does this include, you only write the tests for what you need to implement? For quality assurance, you make sure that if you have tests that were written right as you were about to write the code, then you have a certain level of quality. If that's not good enough, then you can go refactor the system. This allows you to also have continuous regression testing. You don't ever have any functionality in your program that doesn't have a test associated with it. So if you later write something, the requirements change, you go implement something else. If you have tests for all of that code, when those tests fail to pass in the future, you just look back on it and you go, oh, this no longer works the way that I thought it should, that it needs to, I can go fix it. If you write the test later, do you even have a test for that functionality? Who knows? Hopefully you thought about it. Hopefully you wrote it. When you have a defect, you can look at the test suite immediately before implementing this new feature. So let's say you have a bug in an existing program and someone else comes to you and says, this functionality and feature is ready for this merge. If this test is failing, you know not to accept this merge until the bug has been fixed. Fixing this bug in this system is going to be a lot harder if the system grows to be more complex. So it allows you to find the bug and fix the bug in the smallest possible subsystem before you have too many features that makes that process difficult. You end up with lower rework effort, which means that because each test is small in nature, when the test fails, the rework is easier. You get to see exactly which subsets of tests failed. which gets to tell you immediately what is the scope of the problem. Is it a small problem? Did only a test or two fail in one small isolated part of the program? That's gonna be a quick fix probably in that small area of the code. Did this change cause 10 tests to fail across different aspects of the code? Well, now it's not just a value changing in one file, probably. You're actually gonna have to go do a larger scope of what do all of these tests share in common. When you see the failure across all of those tests, you can ask yourself that question. What do these share in common logically? What is it about what I just added or changed that would cause all of these tests to fail at the same time? That level of structure allows you to go target and change much more efficiently. And reworking is a lot of work, as some of these groups have seen, when you actually have to go in and gut a significant chunk of your code and re-engineer a solution, that's a lot of work. If you've written a bunch of tests ahead of time, you can minimize the amount of work that is. So that is a lot of work. Some limitations, because what are benefits without limitations? It's a bit counterproductive, right? You're doing more work. It is hard to learn to do, because from the very beginning, you're used to writing programs that you can visualize from the beginning. It wouldn't make sense to throw someone in 210. Here's your first lab ever in Java. Write a large scale system with a bunch of components. You start with something that is small, it's easy to grasp, so that people understand this is doable. You can focus on very few possible failure points. In the real world, there are tons of possible failure points. So it's not like how you learned. It can certainly be difficult in some situations, because you can't hard code a lot of some of the GUI manipulations. When a user is clicking and dragging, for instance, it's hard to make unit tests that emulate a click and drag of exactly a particular kind of class box in a particular environment, and be able to determine what does failure look like. So GUIs often have some difficult testing situations. Relational databases, web services, you usually need mock objects that return those default values. We talked about mocks last week. TDD doesn't include an upfront design sometimes, so if you don't have that design in front of you, the focus is more on the implementation than on the logical structure of what you're about to produce. So you don't, that may create some difficulties as well. Finally, we have some hard to test code. If you have code that is really difficult to write tests for, you may need some more experience. Finally, designing, writing the code, and testing we're used to those being separate phases in the design process. If you adhere to TDD, that all just kind of becomes a blur. You design, do you design while you test? Do you finish writing tests while someone's starting to write the code? It all becomes a kind of a big blur. We are out of time. We got most of the way there. So my plan now for tomorrow is quizzes should be done. I will try to hand back quizzes. We can go over that. I want to go over the last little bit of these slides. The next thing we're going to look at is a survey of professional programmers and how many of them agree or disagree with certain aspects of TDD. And then we will move on, hopefully getting you some time to work. Questions or concerns before we disperse? All right, I'm gonna go get up sprint 3. I'm gonna go post feedback from the client meeting last week that should have been done last week. I apologize. And we'll hopefully give you some grades for sprint 2 over the next few days. The peer review for tomorrow should be about the end of sprint 2. All right.
Actually, like, did work very hard today, so.
Yeah.
How dare they catch their breaths?